Okay, happy Monday, everyone. I hope you're having a good day. Today's lesson, section 8.3, is going to be all about showing that a quadrilateral is a parallelogram. It's going to be very similar to Friday's lesson when we had to show the features of a parallelogram, basically. So on Friday, what we said is, okay, we know we have a parallelogram. Therefore, we know that the opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. The diagonals bisect each other, and the adjacent angles are supplementary. So today we're doing the converses of all of that, and we're going to say, well, we have this quadrilateral, and we were wondering, is it a parallelogram? And there's 5 ways to do that. So the first way is just as you'd expect. It's the very definition, and we can show that a quadrilateral is a parallelogram by showing that 2 sets of opposite sides are parallel. The second way, again, a lot like what we learned on Friday, we can show that 2 sets of opposite sides are congruent. The third way, we can show that 2 sets of opposite angles are congruent. Now the fourth way, we could show that the diagonals bisect each other. So far this is probably seeming very familiar to you. And you're probably guessing, because this 5th one is a little bit of a wild card. So maybe you're guessing, oh, we just have to show that adjacent angles are supplementary. Well, not really. Because if we knew adjacent angles were supplementary, we could then say, oh, well, if adjacent angles are supplementary, that means that the opposite sides are going to be parallel. So we're not going to use that. There's a 5th method that's a little bit different than what we learned on Friday, and if we can show that one set of opposite sides is both parallel and congruent, that would mean that our quadrilateral is a parallelogram. So the first type of problem we might see is a coordinate geometry type of problem. So notice that P, Q, R, and S all have coordinates, and I'm noticing that all of these coordinates are going to be in the second and first quadrant. So I'm going to draw a pretty big second and first quadrant. I'm not going to worry about the third and fourth quadrant. Oh, and change. Can you make the coordinate of R to be 4, 5? That'll work out a little bit better for us. So I'm just going to plot these 3 coordinates. I don't think you guys need any refresher on how to do that. And then I'm going to join them up to form a quadrilateral. And I'm looking at this thing, and it certainly looks like a parallelogram. It certainly looks like a parallelogram. So, but how do we prove that? So again, we had 5 methods. The first method had to do with showing that opposite sides are parallel. So again, if we could show that we have 2 sets of opposite sides that are parallel, then we can show that it is indeed a parallelogram. So how do we show that sides are parallel? Well, that has to do with the slopes, right? So what I'm going to do is I'm going to find the slope of each of these sides. And I'm going to indicate that I'm finding the slopes, and I'm going to say PS, the slope of PS. Well, that's going to be -1/2. Likewise, the slope of QR is going to be -1/2. So why don't you go ahead and look, and what's the slope of PQ and RS? And hopefully you figured out that the slopes of both of those are 1. All right, now pause here. You might think you're done, but you're not. Remember, a good geometry answer has 3 parts. Part 1 is usually a drawing or some arithmetic or some algebra. That's what we've done here. We've done part 1. The second part involves a math fact. So the math fact at play here, we have 2 of them. The first math fact is that lines with equal slopes are parallel. The second math fact is that quadrilaterals with 2 sets of parallel opposite sides are going to be parallelograms. So we have two math facts going here. So we have to kind of tie together our arithmetic and those math facts into an explanation. So I don't have room to write this all down, but what you might consider is that, well, we can see that PS and QR have the same slope. Likewise, PQ and RS have the same slope. Therefore, those lines must be parallel because lines with equal slopes are parallel. Because we have two sets of opposite sides that are parallel to one another, we know that PQRS is a parallelogram. So, again, all you've done right here by finding the slopes is the arithmetic part of the answer. You got to use your math facts, and then you have to tie them together. Our second method was to show that opposite sides are congruent. Well, how do we do that? We could either use the distance formula, or I prefer the Pythagorean theorem. So what I'm looking at is I'm going to make PS be the hypotenuse of a right triangle. And I can tell that the two legs of the triangle are 1 unit and 2 units long. So I know that PS is going to be the square root of 1 squared plus 2 squared. So that's the square root of 5. I could do the same thing with QR. Now, if I make PQ and be the hypotenuse of a right triangle, well, that's a 45, 45, 90 degree triangle, as it's a isosceles right triangle with legs of 5. So I know that PQ is going to be 5 root 2. So is SR. So there's the arithmetic portion of my answer. Now, the math fact at play here is if I have two sets of congruent sides, then I know that the quadrilateral is a parallelogram. So you'd have to write that up, connecting the arithmetic that you just did using the Pythagorean theorem or the distance formula with that math fact. So I'm going to get rid of that. All right, the next method, remember, we could show that we have two sets of opposite angles that are congruent. That's going to be really, really difficult to do in coordinate geometry. So I'm not going to use this one. Showing that angles are congruent, for example, showing that angle Q is congruent to angle S is very difficult to do using coordinate geometry. So I'm not going to use that one. But I am going to use, and probably this is my favorite, showing that the diagonals bisect each other. So let's draw those diagonals. And let's go to the definition. Here's our math fact, the definition of bisecting. Well, the definition of bisecting means that those two segments would intersect each other at their midpoints. So think, what do we have to do? Well, if you came up with, well, let's find the midpoint of QS and the midpoint of PR, you'd be exactly right. So let's find the midpoints of our two diagonals. So the midpoint of PR. Well, I'm going to go back up to my coordinates up here. And I'm going to average those x coordinates, so -3 and 4. And I'm going to average the y coordinates. And so the midpoint of PR is going to be 1/2, 3. I'm going to do the same thing for QS. So why don't you go ahead and do this, and then you can just check your answer. So, looking at that, both PR and QS have the same midpoint of 1/2 and 3. That's the arithmetic portion. That's the first part of our three-part answer. So what I might add to that to turn it into a complete answer is something like this. Well, PR and QS both have the same midpoint of 1/2, 3. Therefore, they bisect each other. Any quadrilateral whose diagonals bisect each other must be a parallelogram. So that's how we know that PQRS is a parallelogram. Right? That's probably my favorite. I think it's the simplest, but you can use any method that you want. The last method, showing that one set of opposite sides are both parallel and congruent. I'm not going to show that one, but that would be like a combo of method 1 and 2. You'd pick one set of opposite sides. Maybe you just pick PS and QR, and then you would show that their slopes are the same, so therefore they're parallel, and that they have the same length, therefore they're congruent.